Dear colleagues, I thank you for the opportunity to provide our report, Artemia Biodiversity in Russia. On the Russian territory, there are many shallow, well-heated, mineralized reservoirs along the southern border of the Azov Black Sea coast, along the south of western Siberia to the Sayan Mountains. The main inhabitant of these highly mineralized lakes is Artemia. The slide shows some of the latest publications of our research team, which I will use as a basis for my video presentation. The history of studying salt reservoirs in Russia began with the development of the natural mineral resources of these lakes. Lepekhin and Gmelin visited lakes Elton, Baskunchak and other lakes of the Volga steppes and the Caspian lowland. They provided the first information about the self-sedimentation of salt lake. Academic Pallas made important contribution in the study of salt lakes. He was the first to point out the role of groundwater in the nutrition of the salt lakes of western Siberia and the marine origin of the coastal lakes in the Crimea. Shmankevich noted the effect of salinity on the appearance of Artemia. He kept Artemia in water with different salinity and found change in the appearance from salinity. Gaevskaya devoted her works to environmental issues and in particular the effect of salinity on Artemia. Her articles were translated by the famous German ecologist Volterek and published in 1922. Russian scientists have the main merit in developing methods for determining stocks of Artemia cyst and their recommended catch. Hyperhaline lakes of Russia are dispersed over a large area from the Crimea to Tiva in strip along the southern borders of Russia. Thus, the distance from Lake Svatikova in Tiva to Lake Yarlangach in the Crimea is 4,450 kilometers. The conditions of such vast area are very significantly. This also applies to seasonal and annual temperatures and the presence of precipitation. In Russia, there are two main centers of concentration of Artemia population: Black Sea Caspian Basin and southern part of Western Siberia. Artemia has also been found in the southern part of Eastern. In this way, the area of Artemia in Russia is confined to the arid and semi-arid climatic zones of forest steppes and semi-deserts. These zones are characterized by large annual amplitude of air temperature, which can reach from 50 to 70 degrees. During the cold period, precipitation falls in the form of snow in western and eastern Siberia. The summer is warm. The average temperature in July is from 18 to 26 degrees. The annual rainfall varies from 100 to 600 millimeters. Common characteristic of the climate is predominance of evaporation over precipitation in the annual aspect. The slide shows the list of the main commercial and conditional commercial lakes of Russia. There are 20 main reservoirs where regular catch is conducted. They are located in the Altai territory, 4 lakes, Kurgan, 7 lakes, Omsk, 2 lakes, Novosibirsk, 7 lakes. The total area of the main lakes is 21,929 hectares. The average depth of these lakes ranges from 0.3 to 4.9 meters. The salinity in these lakes ranged from 40 to 406 grams per liter, with long-term average values from 103 to 265 grams per liter. A list of conditionally commercial lakes includes lakes with irregular catch or lakes in which catch is locked. There are 80 of them. The total area of these lakes is 170,646 hectares. The average depth of from 0.3 to 2.0 meters. Salinity is from 25 to 402 grams per liter. However, this list does not include many dry lakes of the Crimea and Western Siberia. Small saline reservoirs where the presence of Artemia periodically recorded. I will not stop on the basic Sea Caspian basin. My colleague Elena will tell you about it. I will tell you about the territory of Western and Eastern Siberia. The main commercial reservoirs are concentrated in the south of Western Siberia. This entire vast territory is located in the southern part of the Obertish Basin. It includes the following administrative regions: Chelyabinsk, Kurgan, Tyumen, Omsk, Novosibirsk regions, and Altai Krai. The fund of Artemia lakes in Western Siberia is very significant and has from 80 to 100 lakes, with total water area of 1,600 square kilometers or more. The salinity is from 30 to 320 grams per liter. The Yandex maps show the location of Artemia lakes in Western Siberia. Chelyabinsk, 6 lakes, Kurgan, 18 lakes, Tyumen, 2 lakes, Omsk, 2 lakes, Novosibirsk, 18 lakes, and Altai region, 8 lakes. The study of Artemia in Western Siberia has been conducted by VNIROS staff for several decades. During this time, the fund reservoirs of Artemia lakes were determined. Methods for determining these reservoirs and the forecast of catch for subsequent years were developed. As a rule, only half of the lakes are developed by catch, due to the fact that some of the lakes become unproductive due to low or high salinity at one time or another. Within Eastern Siberia, salt lakes have been found in Khakassia and Tiva. In Khakassia, 2 Artemia lakes were known, Tuz and Pervomayskaya. 2 Artemia lakes have been discovered in Tiva, Svatikova and Cheddar. In addition to these lakes, there is another lake with high water mineralization rates, Dushol, located at a distance of about 100 kilometers from lakes Svatikova and Cheddar. The question of special definition of Russian Artemia populations remains open. Recently, molecular genetic methods for studying mitochondrial and nuclear markers have been used as a tool. The existence of number of bisexual species has been proven. It is also known that Artemia species are represented by bisexual populations with a diploid set of chromosomes. At the same time, the majority of population in the Eastern Hemisphere are polyphyletic, obligate, parthenogenetic population with different ploidy number. Identification of many species of Artemia does not cause difficulties by molecular genetic analysis methods. Artemia urmiana, Artemia tibetiana, and parthenogenetic populations belong to the aeration haplotype complex. There are difficulties identify them. They are probably related to their recent divergence from common ancestor in the late Pliocene. As a rule, parthenogenetic forms of Artemia live within the Russian Federation. The issue of identifying Russian population in scientific and practical task. We analyzed 56 samples from Artemia cyst from different years of collection from the Aral Sea and lakes of Russia. We used the method of sequencing fragment of the cytochrome oxidase 1 gene of mitochondrial DNA. Analysis of haplotypic diversity was performed for the cytochrome oxidase 1 gene. Some paired reads was revealed in the studied samples. After filtering by quality, 17 mass haplotypes were identified, which is 5% of the total number of sequences obtained in the sample, and 60 unique ones represented in more than 0.5% of the studied population. The distribution of mass haplotypes shows that 8 are dominant in the identified 17 haplotypes. The only haplotypes present in all samples with a dominant concentration is more than half of the studied population. The second haplotype was found in 37 studied Artemia population. The result of clustering of the studied population of Artemia by the UMAP method are presented on the slide. Clustering demonstrates a clear division of the Artemia into 3 separate groups. The first group is represented by samples of Artemia from lakes exclusively in the Kurgan region. The second group of lakes turned out to the most numerous. It included 35 populations Artemia, including from Uzbekistan and the Crimea. The third group includes Artemia mainly from the lakes of the Altai territory and the Omsk region. All the studied population belong to Artemia with a parthenogenetic type of reproduction. The exception was population from the Sivash Bay in Crimea and Lake Malaya Shklo and Bursol in Altai territory. Interestingly, bisexual Artemia from lakes Malaya Shklo and Bursol clearly separated from all other population when clustering haplotypes using the Statistica program shown slide. While the bisexual population from Sivash Bay did not stand out according to the used markers. So the studies of cytochrome oxidase 1 are suitable for determination of the haplotypic diversity of Artemia in different habitats. However, it does not allow for sufficiently reliable identification of Artemia population in the northern part of Eurasia, with the exception of bisexual population of the Altai territory, probably belong to Artemia sinica. Dear colleague, I want to end our report the main conclusion. It is necessary to continue this investigation together. Thank you for attention. The best regards.